Hello everyone, welcome back to the good stuff we've been doing. In this video we will discuss about homogeneous integral functions, and the reason I specified integral function is that it should not be confused with the general case of homogeneous functions discussed in calculus. In this part we are only going to focus on functions that integral functions are functions that the power of x is integral and positive. Let's say things like x squared plus 2x plus y, let's say 3, or we may have x squared y plus xy plus xy cubed. Okay, all the power of x and y are either they are either 1, or they are not having something like s y to the negative 2 power. So that is what we mean by integral. Like, this is not allowed. We want just a positive integer there for y. So that is why I specified that here we are going to deal with homogeneous integral functions. So here when we look at these functions here we list here, the variables here x and y here, this is x to the first power, so the degree of this variable here is 3, the degree of here is 2, and the degree of here is 3. So here they don't have equal degree, like 2 is actually a problem here. So we say this case this function is not homogeneous. We mean not homogeneous. In this case we mean that the degree of each term are not equal to each other, so it's not homogeneous. What about the case whereby we have x squared y here, then we have plus x y squared? In this case the degree of x and y is, the degree of xy combined is 3, likewise here is 3. So since the terms here have equal degree, we say yes, this one is homogeneous. So this case is a homogeneous function. Let's consider the general case for homogeneous function would be, let's see, first of all we have to consider the case whereby it's just two variable, let's say two variable case. Now if it's of degree 1, first degree, if the degree is equal to 1, it should be in this form, ax plus by. So this is the two variable case, because here it's something like 3x plus 5y, where here a is playing the role of 3, because the highest power of x here is 1, highest power of y here is 1. Now since we specify that it's a degree 1, we cannot have something like 3y square also. So things like b plus c x square cannot be here in this case here, because we simply specify that we only want the case of degree 1. Now assume that it has a second degree, how would it be? So the degree is 2. In this case what we have here is that we have an x squared term here, even for y squared term here, but then we'll be having something like cxy, because even after we have done the x squared term and the y squared term, this term here, the first power, second power, like their degree is 1. So what I'm listening here is that this is general case in which you can see a homogeneous function. For example, 3x squared plus 5y squared minus 7xy is homogeneous, and it falls under this case of degree 2, where the degree is a second degree homogeneous integral function, because here the highest power of the unknowns are equal, 2, 2 and 2. So if you count 1 and 1 you get 2. So I'm listening at the most general case it can get. What about the case whereby it has a degree 3? How would we represent it? Well, this is how we can try. We can start with, say, for degree 3 we can say, okay, here we have ax cubed, yes, we may have by cubed, this case around. We may have c, but we will have x squared y, then we have d, we have x y squared. I think this is the more general case, because there is no other combination we can pick again that will give us power of 3, because this is 2, this is 1, this is 1, this is 2. Yes, so I think we are finally done. So we have 4 of them in total. And then for the fourth case here, what if we have degree 4? just like before we have to the fourth power, but then we'll be having y b y to the fourth power, and we'll still continue with this cx y cubed. We'll then be having dx square y square, and then we'll have ex y cubed. Just like the power of x is decreasing and the power of y is increasing, just they must all be equal to 4 in this case here now. So this for two variable case. Let's see how we can construct the general case for three variable. So for three variable case, if it's degree 1, we can have ax plus by, but then have a plus cz here, because here we're dealing with three variables. Then the degree 2, second degree form would be, let's see, here we have ax squared. Of all the y, all the other we have a square. The next is that they will combine, so we have cxy plus dyx, no yz, plus ezx. So that's how they combine. They must have a degree 2. And even for the three variable case here, it's just the cubed, by cubed, cy cubed. Then we'll have, it will be a plus of how do we go next? We'll have I think we'll have x y square, but then we'll have ce x, even with xz square is present, then we'll have probably f yz square, things like this will present, and then I think that is all we have listed. We don't have any x, that is all of them are degree 3 and the 3 letters have appeared. Then we'll have plus g x y z. So I think this is the most general case. Let's say 6. This is the most general case it should be for the three variable case here. So what we did in this video essentially is to discuss what is homogeneous function and the general form in which they can appear. In the next videos we'll discuss more properties of homogeneous function, and then we'll learn the method of undetermined coefficient, I think. So please subscribe to the channel and have a nice day ahead. Thank you.